Hello everyone, my name is Alexander Zelenin.
Hello for everyone, my name is Alexey Khaletsky.
Today we will start with finalizing yesterday task about determining DNA health. Then we go back to simplest,
New one.
yes, to new one, more simplest task regarding dictionaries. So the problem yesterday with determining DNA health was mainly that I not correctly understand the task itself. I was presumed that when we found a letter, when we found the combination, we need to calculate for this combination, and it was work for the example that was initially. But originally, when I reread the task itself, I understand that we need to count both of them. So, for example, if we have combination of AA and both A and AA are in combination, we need to count both of them. So, for example, if we will have two letters AA, it will be 2 times A, so 1 plus 1, 2, and 1 time AA, so it will be 6 total for both of them. Um, it was a bit unexpected and like just randomly for some condition what we had right yesterday was work. But generally it's not a big problem. Instead of just returning gen, we will return array of them, or we will just count health itself here. So instead of finding gen, we will make a finding gen health like this. And we'll move this part. We'll move this part here. So it should be like this. So we go to letter. If this letter exists, we will count some health and we'll return health instead of the gen itself. So let health equal 0 initially. We will return health, and for every gen we will calculate what is required. So here we have gen result. Instead of gen result, we need to have like current result. Since I move this code from the upper one, and the variable, the name of variables is different here. So we have a cycle. We have gen current health, and we cannot just here just for health, since we just need to return health itself for like all combinations. So everything is fine here, and we need to modify code here to find strand health here instead of no, sorry, not strand health. We will increase strand health by value of find gen health with same arguments. So this one will go from here, this one will go from here. So we modify strand health. We increase, I think this one also should be good. Oh, from here. Let's try. That's fine. That's just a small error. There's another thing that we need to pass here is first and last. So like range of the indexes itself. So we will just pass first and last. Not a big problem. 98. We need to check with just current, not the current letter, because I move this code like a bit in another position, so it's just an error because I move code and sometimes it's hard to maintain. So the first example worked fine, but for other ones it's also work fine. I will presume that one of the cases will fail of timeout, and this algorithm, yes, one of cases failed due timeout, but all other cases run properly. So we got about high score, but like one case failed, so we didn't get 1.4. We will not optimize code right now, so terminated due timeout means that our code is not optimized well. So we will not optimize our code now, so it will fail for now. Maybe we will do it next time, like on next video or something like that. We can calculate complexity of this, and complexity will be high. Do you want to calculate complexity, or we will go to another task? What do you think?
Well, if you can explain it quick, I think better to explain it.
Okay, let's go. Let's go then. So we have our function determine GNA. Let's start with this. We have a structure. First of all, we will start with space complexity. Then with time complexity. Space complexity is how memory consumptions is changes over time. So if we will got more gens, more strengths, more health or whatever, how it will affect our algorithm or memory consumption. So first of all, we have a structure here. Structure will be chain like this one, and it probably will have like very deep structure with a lot of results or whatever. Generally we will have like one entry for every gen. So it doesn't matter where it will be. It will be like some nested structure, or will be some duplicated structure, and will be additional entry in array. But generally for like every gen, we have entry in our structure. So it will be on gen's length. Let me write it like now, like this for now. We have also two variables, minimum and maximum, and it will be just O1 since it's just variables and nothing affect them. We doesn't store any other information during everything, during all the code. So the memory consumption will be just ON. So memory consumption's like in a good shape. I presume we need to use small n. Yes. For time complexity, it will be more complicated, but let's see what we will have here. We have two parts, originally three parts. First is to generate this structure, and second to go through this structure, not through the structure, sorry, Second, to go through strands, and inside strands we're going through our structure to find some result. So for generating structure itself, what we have here, first of all, we go through all gens, so it will be at least gens length. We're starting with that. Inside of this, we are going through gen itself, and depending on the length of the gen, we're creating nested structure for it and pushing it. So this operation is cheap, but this one going through gen itself, like letter by letter. So for example, if you have not this, but here we have only small examples, but let me just show you example from here, so we can have DNA with like big length, and I think this one is not so big, because for example in this file we have like megabytes of data with DNAs, and a lot of them have maybe about just 10 symbols. I remember that in another example there was like 100 symbols, for example, so they have big length. We have limitation up to 10 million, items. Sorry, not items. 10 million items, but the length of DNA itself will be up to 2 million or something like that. So the string can be really long, and here it depends on the maximum length of gen itself. So it will be like multiplication, gen length, like max gen, there is no such thing as max length, but I just want to write like this for showing how it affected. Generally, we cannot use anything from incoming variables to use it here, but we have this in conditions, and we can rely on some numbers from the condition itself. Maybe there is some number s, right? No, s is count of strands. Okay, it doesn't matter. Anyway, we have like multiplication here. Then we have O strands length for this cycle. Inside this cycle, we have another cycle regarding the DNA combinations. So DNA combinations will be like this: C, A, B. So for this, it will be O combination length. And combination goes from the strands itself. So it will be already like this one. And inside of this, we are calling find gen health. And find gen health can be also not as the smallest one. We have here the first cycle that go through combination length again. One more time. So, and inside of combination length, we also, for every result in chain, we have another cycle that go through results. Like in worst case, we will have results from all DNA like in one gen, and it will took uh, up to gens length again. So O gens length in worst case. So it will be multiplied like this.
Mm-hmm.
So it goes for to this position like this, and we need to multiply it from here to here. So it will be like combination in square and multiplied to gens length, like this one. Wow. And in the end we have sum of this. So we have gen length multiply. So let's just write it here. Multiply and plus this one. So let me write it in 2 lines, otherwise it will be not clear enough. Like this. So we can see that complexity is very high and depends like on everything. Generally, it's possible to optimize it a lot in this part, because like combination length add a lot of complexity to our complexity. And one of the way to do this is to use some caching mechanism to calculate it only once. So it will be possible to calculate for every combination just once, and I presume in worst case we will end up with something like that. But we will leave it for like next time. And also to find, there was somewhere a comment, yes. So I just go through all the items in the array, but in worst case we will need just one item in the end, for example. So it's possible to change just going through an array to binary search, to change the search from like ON to O log n, which much better. So there is a lot of possible optimizations for this algorithm, but I think we will go to next task. So for now, like we are fine with that, but I hope we will get back and optimize this code. Yay!
Okay, let's do it. Congratulations.
So let's go for the next task in like interview preparation kit in dictionaries and hash maps. We have a task called frequency queries. So the thing with this task is next. So set a video on pause if you want to read. I will explain it by my own. We get a list of operations. We can have three types of operation. The first operation with number 1 is insert number that mentioned on the second argument in our data structure. The second operation delete one occurrence of this number from our data structure if it presents. And the third one, check if any integer present in our data structure, and we will need to print 1 or 0 for each of this operation. So it will, how many times we need to print will depends on the incoming query and not on the task itself. So for example, in this case, we will receive like 1 1 2 2 3 2 1 1, and here is like explanation. On 1 1 we have operation add number 1, and we add in our storage number 1. Then we have operation like delete number 2. We doesn't have number 2, so we doesn't do anything. Third operation is to check if there is number 2 in our array. There is no number 2 in our array, so we return 0. Then we add another number 1 to our array, so we have already 2 of them. Then we add third one. Then we ask to delete one of the ones. And then we check for number 2. Okay. With this operation, we will need to check is any numbers presented an amount of times. So in this case, 1 is presented exactly 2 times, so we are printing 1. Okay, I was initially thinking that we need to print if the number itself is presented, but originally we need to print how many times is presented. So what constraints we have? The number of queries is q, which from the 1 to 1 million. The numbers is from 1 to 1 billion. But every operation can be only 1, 2, or 3, since we have only 3 operations. And the maximum number that we store for query will be up to 1 billion. So output format is just to print 0 or 1 when we need to check. And like that's all. I think we will not go through other cases. It's not required. So what you're thinking?
Can you move a little? First of all, I think we should set what do every function, I don't know, or
so
for
we
example,
have insert, delete,
one,
and check.
Yes. Insert, delete, and check. We should first of all we should set what insert, delete, and check do.
Okay.
Then we should do this operation in our queries. We check the first symbol. If it's 1, we insert, then 2 we delete, then 3.
Okay. But the question here is next. How we will store our data, in what format? Because if we will have the format like the one is offered to us, then for every check operation we will need to go through all our array and check it, like check every number and try to find is it presented or not, and maybe it's possible to do by some more efficient way.
Can we check only our array? No, we can't. Maybe we should storage somewhere every number we had in the previous operation.
Okay, and what we will do with that?
And then check just this storage when we had these numbers and use it in resolve?
Okay, I will try to ask a bit differently. If we need to find count of some numbers, and they offer us to insert this data to our data structure, but the data all the time is the same. What we can store instead of array like 1, 1, 1? Can we store this data somehow differently?
Like numbers of these ones. For example, if we have 1, 1, 1, can we just storage that we have 3 ones? No?
Yes, exactly like this.
Mm.
So if we will do something like that, we will able to make very fast operations.
Mm-hmm.
And another thing is when we want to check is there some number presented 2 times, we generally can store additional data structure which will store count of numbers that have exact amount of numbers. So we'll have like 2 data structures. And if we will have this, we will able to find it with like O1. For inserting, it will be a bit harder, but not too much. So let's start writing our code. I will copy this just to put it in code somewhere here, like this. So we have queries. In every query we have operations. So let's create our dictionary, call it numbers. In numbers we will store something like this: 1, 3, 2, 1, and so on. So we are going through queries, and for each query we have 2 things. First is operation, and second is number itself. So we will use switch construction here. It's like a bit new construction, not the new, but we had not used it before. The thing with this construction that we can provide like something like operation, some variable, and we will have option what we need to do for such operation. To provide an option, we need to write cases. We have 3 cases: case 1, case 2, and case 3. So like what we need to do if 1 here, what we need to do if 2 here, and what we need to do if 3 here. So if we have 1 here, we will increase, so we will find numbers with our number, and we will increase this by 1. But originally, sorry, I will write it a bit differently. So if it's not presented, it will be 0. If it's presented, then we will take the current number and we'll add 1. For insert. Second one is delete. And the third one is check. So for deleting, we will do something like that. First of all, we will check that this number exists at all. If it doesn't exist, then delete operation doesn't do anything here. If it exists, we will reduce it by 1, but we also need to check that it's already the value, the count of these numbers already is greater than 0. So it exists and it's greater than 0. Okay? I think we can leave just this one, because if there will be no value, like no value is not greater than 1. So greater than 0. I talking right thing, but write the wrong code. But this time I fix myself. So we reduce the number. And third one is to check if we have this count of these numbers. So let's create another dictionary that will store counts of some numbers. What we will do here is one second. I want to split this operation in two operations. So it will be like 0 initially, and then we will add 1, like this one. So we getting or setting default value, and then we add 1. So when we will add, when we increase number, I want to reduce previous counter, like if one second. So if it was greater than 0, then we will need to reduce previous one by 1. And after this, we will do something like counts or new result. So it will be like a resulted number. And for this one, we will assign or 0 or add 1. And here we need to reduce this one by 1. Okay. When we deleting number, we will need to do something like that, but like in reversal order. So before removing number, we will reduce number from the current one. And for current one, it's guaranteed that it exists, so we don't need the default value. So we remove this number, and we will add the number for the previous one. So it will be like this. Yes. Maybe it looks a bit strange, but I will go through this one more time and explain what is happening. So, and the third operation, finally, we need to check is do we have proper amount of some numbers or not. So we can just check, like if counts of this number is greater than 0. I think that's all. That's all condition. So we need to print. We need to print or return result. 1 second. We need to. 1 second. What is happening here? We need to return an array of results. So we will have a result that will be array with our answers. And we will populate it with our answers. So we will put some value to this array, and this value should be 0 or 1. So if the number of such combination is greater than 0, then everything fine and we add 1. Otherwise, we add 0. And at the end, we need to return our result. Okay, let's see. We have for each. Okay. Just a typo. I write it from the small letter. Okay, looks like test cases work well. Let's submit our code and see how it works. Yes.
Hooray! You are good.
Great.
You are good in this.
After a hard task, this one goes much easier. So let's see what we have here and why we need to have like 2 objects instead of 1. How it help us, how it affect complexity and so on. So let's start with calculating complexity. So space complexity and time complexity. Do you want to try to calculate it by your own?
No, it looks a little complicated for me.
Okay. So generally we have 3 objects where we store something. The first object that store numbers. Like in worst case, this in worst case we will have a lot of insert operation with different numbers, like 1, 2, 3, 4, 5, and so on. So it's possible that the numbers will be equal to the queries, to amount of queries. Then we have counts. The interesting thing here, if we have same numbers, like only insert like 1, 2, 3, 4, 5, and so on, we will have only one combination of each other. So in this case, it will store just one number, just one entry. But if we will have some multiply insert of the same number, or so my assumption that both of these numbers and counts should be equal to queries count, because if we add the same number, then for the numbers itself, it not contribute at all. I mean, we will not add any additional data to the numbers object. We will just increment the one value to another, like from 1 to 2, from 2 to 3, and so on. But when we move from 1 to 2, then we will modify the count itself. So we'll have like a lot of combination, a lot of number that presented just once, and one number that presented like 2 times, and so on. So I presume that both of these objects combined will have queries length. I mean space complexity. But generally, if we will determine them independently, both of them will have complexity of queries length. But originally, maximum memory consumptions of both of these will be query length. And for result, we will have maximum again queries length. Again the same, because in worst case, like all the query will be to check number, like check, all operation will be third one. So in the end, if for example, if we have 100 queries for check for one, and we have no numbers at all, we will just return 100 of zeros. It's possible to reduce this part, and instead of returning result, just print result like here without storing it. So we can read off of this if we want to. But we don't need to do this right now, because I think this result is good enough. We have Q letter. So space complexity will be OQ. That's all. Because generally that's everything that we store and result. So, or we can present it like 2Q, but we drop the numbers and leave only letters itself. So, okay. For the space complexity, everything fine. Then we go for time complexity. Maybe you can count the time complexity?
Let's try. Well, first switch operation it's 1, then in switch operation we have
Like one of these three operations happens. What is complexity of these operations? We just
0.
assign variable. Zero is not possible. It's always one.
1.
Okay, for this one.
1.
And for this one. We add the one variable to array.
1.
Yes. So all of them is 1.
So 3?
No. First of all, it's not possible to have 3. Again, it will be just 1. But we have a cycle here. We're going through our queries.
Yes. This some. I forget all English words. Sorry, it's some complicated for me.
Okay, if we go through every element in query, for example, we need to count from 1 to 10. How many times you will count? Just you as yourself.
10.
If you will need to count from 1 to 100, how many times you will count?
100.
Okay, so how the count of numbers you need to count changes depending on the numbers you are getting. Like if someone asks you to count 100 times, you count 100 times. It will be like an operation, exactly this amount that person asks you to do. So it will be OQ again. So time complexity total will be OQ. As an example, if someone will ask you to count like combination of something, for example, if we will have 4 numbers like 1, 1, and the person will ask you to find all possible combination of this number. Let's have 1, 2, 3, 4, for example. All possible combination of 2 numbers. You will do like 1 and 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, 3 and 4, right?
Mm-hmm.
So you do for every operation all next numbers. So for such operation it will be like O(n) square, because instead of 4 times you will do it like 1, 2, 3, 4, 5, 6. You will do it 6 times.
Mm-hmm.
But if you will have like a fifth one, you will do it again like for every of the numbers. So it like increasing dramatically with each next number. So when you have like 10 of them, you will have a lot of combinations that you need to count. But when you just need to count from 1 to 10, that's easy. And even someone asks you to count to 1 million, it's not a big problem. Yes, it will took some time, but it's not a problem. But if someone asks you to find like all combinations up to 1 million, and then you will need to do it like 1 trillion times, then it's going to be complicated and you will need to change your algorithm. So
I see.
I think we're done for today. We improve the previous task. We solve the new one, and
Mm-hmm.
it looks good.
Yeah.
So
Thank you.
I hope we will continue tomorrow, and we will finalize dictionary challenges, and then we'll go for another ones. So thank you everyone for watching.
Thank you, Alexander, for
Thank you,
explanation.